Well, greetings everyone and welcome back to Rob's workshop. So as you can see from my little drawing, I've decided to go ahead with fitting counterbalance weights to the crankshaft of my Stuart twin launch engine. This is my final design, which is basically a quadrant. I'll be making them out of brass. I could have used aluminium, could have used steel, could have used all sorts of things, but I like brass, so brass it'll be. The stock is 1/4 inch wide. To match the crank web thickness of 3/16, I'll have to shave a bit off both sides of the stock by a 32nd each side, and that'll match nicely with each crank web. They're secured by two 70A bolts that go through clearance holes in the weight into tapped holes in the crank web. What else? When I was drawing this up, I thought I could make these on a mandrel in the lathe. Just simply hold a bit of stock, chop a bit off, and then turn the outside radius, nay bother. And then I thought, I wonder if I could, machine this relieved part the same fashion, so I'd have like a matching or concentric curve there. And when I drew it out, it didn't look right. And based on all the engines that I've worked on in my career, I don't remember seeing any counterbalance weights with a matching curve there to the outside. They've always been straight, so straight it's going to be. I'm sure it'll be fine. So the first thing I'm going to do is drill and tap 2 holes in each of the 4 crank webs, 7BA, 1/8 of an inch or 125 deep, and I'll get back to you. Right, I'll just drill these 2 small holes parallel to one side. They're going to be rotating around this little adapter, which will go in the center of my rotary table, and I can do the curves and so forth. Yeah, I could have flipped one of these over to save a little bit of material, but there's a method in my madness. I want these 2 in line anyway. So onwards and upwards. So this is the setup. I've got a pin in the center of the fixture plate, and that's located underneath the quill center line. Now the reference surface here, I clocked until it was dead straight on the y-axis, clamped this down temporarily, and then moved my nice straight bit of tool steel up against to touch the reference edge and clamp that in place, and I've just clocked that just to make sure it's still all very straight. So what this means is that in going forward, when I come to machine the second quadrant, I just move everything down and everything should theoretically be nicely in alignment. First operation is going to be machining the relief on this side, 32nd of an inch according to my drawing, and then I'll flip it over and do the same on the other side, and next operation after that will be the 2 curved outside profiles. So we'll see how that goes. Okay, I've got the milling cutter set up. I've calculated the distance from the center of the hole, which is representing the center of the crank pin. Distance from there to the feature that I want, minus half the diameter of the cutter, so that I can machine straight away across here. and reduce the thickness by the required 30 seconds. So here we go. So I'll just touch off and then go down 30 seconds. Zero the quill BRO. Then go down 41 There we go. I don't need to go all the way across that face there because I only need 100 thou before it's machined away anyway. So I'll flip it over and do exactly the same on the other side, but I'll do all that off camera. So off camera I took the piece out of the jig and measured this reduced thickness here, and it's about 1 thou each side to go, which is fine because I can polish away the machining marks. Next step, I've moved the cutter across to the required radius plus half the diameter of the cutter, and it looks pretty good. So I'll just go down and machine the outside curve. So I've moved the workpiece across. I've already done the outer radius on this end, so I've moved it across, stuck it back on the pin in the centre, and I'm doing the profile on the second part. So that's the basic profile done for both pieces. Whilst I've got it in this jig, I've changed over to Jacob's chuck and a chamfering bit, and I've come off the outer radius a wee bit and brought the cutter down until it produced what I consider a reasonably looking good chamfer, and then I've locked the quill, and then I can use the same setting for each of the 4 chamfers. So this is the last one now, so I'll do that. I'll bring it down to my set point, which is there. Lock the quill. have a look. Oh, nice. Okie dokie, let's go. So a little recap on how I've reached this stage now. The rotary table was centered under the quill and the scale on said table was locked at 0 degrees. I aligned this with the y-axis and fitted a fence, bit of tool steel actually, next to it so that the whole arrangement was repeatable if I wanted to remove this, which I had to. So the first operation was this curve here. I know that's 0. The radius, required radius, was 0.728, and then plus the cutter radius puts me out here. I've got the figure 0.8264. So the center of the cutter will be here, and then just wind the table back and forth to full depth. I did this for both pieces, flipped the piece over obviously to chamfer top and bottom surfaces. I just used a simple chamfering tool, and once I got the chamfer that I wanted, lock the x-axis anyway, and made a note of the depth of the cutter, so I had 4 chamfers that all looked the same. Now these slots were done by rotating the table 50 degrees and locking it, so then we end up with a bit like that. Now the guideline here of course is on center with the pin, so I need to offset again half the radius of the end mill up here, and then back and forth to depth. Likewise for the other slot, it's rotated the other way 50 degrees, locked, only this time the offset, half the diameter of the cutter, is in that direction. And it went very well, I must admit. Back to 0 degrees, and this parallel to the y-axis. Just offset the cutter. I needed 0.3065 from the center, minus the radius again. 3065 gave me 0.2081, so I'll move the table across 0.2081. Touched off, set a 0 on the quill DRO, and then gradually went down to a depth of 0.03125. Flipped it over without changing any of the settings, went across on the other side. So I've got relief on both sides of the 2 weights. Next operation, I'll lop these off close to the edge there. This part here only needs to be 0.1 of an inch wide from there to the edge. So I have a cut off close here, and then I'll make some kind of a jig so that I can machine that bottom face to the required 100th thou. That's it. I'm going to repeat it on another bit of brass later on, but for now that will do. We'll go on to the next step. Right, that's all 4 quadrants separated. Next operation, I need to reduce the height down to 5215. I was going to make a jig for this, but I can't be bothered. So instead I'm just going to use my protractor, stick it in the vise that way up, bring my protractor down. This sits on the top of the fixed jaw, which I know is dead level, and then move the part around until we got contact here. Clamp it up and then machine down until I've got the depth that I need. Next operation after that, flip it vertically in the, whilst it's in that position I should have said, edge find to get the center of the piece, and then the center of the width of the material, and then move across half this pitch, which is 0.12 either way, center drill, and then drill clearance hole for 7BA, which is 2.6mm number 38 drill. And I won't go right through, I don't want the drill snatching, so I'll go down about 450 from the top, machined top, and then final operation when I flip it round in the vise and I machine this slot, hopefully the holes will break through. But first of all, I do that bit, machine that down. I won't bother filming it because it's pretty straightforward, but I'll take some still shots as I go along. So all 4 segments done. Final operation now is to cut out this slot here for the bolt heads. Fairly straightforward operation. Just set it up in the vise on top of a parallel, edge find the center, bring the cutter down to 1701 final depth, and then walk it left and right until I've got the required width of 4400 it says on my drawing. So that's the last operation. Won't be long now. Right, that's all 4 pieces done. I'm quite pleased the way they turned out. I made 2 changes to the original design. The first one was the depth of this recess here. I reduced that to 125 from the original 1701. I did that because I found some 7BA screws with 8BA head sizes, and they look a little bit better than the standard 7BA size. So that was one. The other thing was the recess to clear the bearing caps and so forth. I had to increase that because a dummy run, a dummy assembly proved to be problematic. It was catching various parts of the sole plate, particularly the bearing covers, because there's still castings at the end of the day, and they're not they're all different sort of shapes basically. So that was the two things I did. And that's it. Just a bit more polishing, and I'll assemble it on the crankshaft again and in the sole plate, and I'll get back to you with the final result. So there we have it, all done. Quite pleased with the outcome, not too bad at all. Everything clears everything else, thank goodness. I suppose the next job will be I need to do the other connecting rod. Actually, I've been putting that off for long enough. Piston rods and pistons I think will be probably next. I need to get those done as well. So anyway, until the next video, wherever you are in the world, thanks for watching, thanks for subscribing, and I'll see you soon. Bye now.